Hi, I'm Gary, and I want to show you how I use Cloudy. Welcome. Here we are at a command prompt. We're in the homework directory. We'll have a look, and there is exactly one file here, M16.n. This is the file we looked at before, and it's a published model of the pillars of creation, the M16, the HST image. So what we're going to do is compute it. I've set up a run script. Remind ourselves, I've placed it on the path so I can run it way over here. That's the location. It's in this bin directory. Remind ourselves what's in it. Uh, Typed it out here. So this is the full path to Cloudy down to here. Then there's the Cloudy executable, the -R option, the name of the file, $1, and we're sending standard error out to this error file. So what I'm going to do is type run M16, let it go. Okay, we're done. First thing I compulsively do is look at what's at the tail end of this file. So it says Cloudy exited OK, the very last line. Now let's see what we've accomplished. Let's do an ls on this directory. We have a number of files now. So we have the .n file, which is the main input file that we've used the commands. And Cloudy created the main output file, m16.out. And we'll look at that very briefly. So that's the main output file. There's a number of other files, and these were produced with the save commands that were included in the input script. We'll go over those when we start making plots of what this looked like. But for now, let's have a look at m16.out to see what it is we've accomplished. We're looking at the output file, and this is Hazy 2, the start of Hazy 2. And the first chapter in this volume does go over a complete description of the output. Here's the beginning of chapter 1. It's going to go over much of the same material we're going to see very briefly on the screen in just a second. But this goes over line by line, explaining what's in the output and what the physical meaning is and how you can use it. So I've opened the output file and just going to very quickly go over what's in it. We begin with this block of information that shows you what was in the input deck in M16.n. So the block of information here tells a lot of information about the incident radiation field, the light that came in to strike the gas. This is the gas phase chemical composition. So that's the 30 elements included by default. Many of these are not very abundant. Then elements are present in both gas and the solid phase. So this is the grain composition. For the grains that are included in this mix, these are the elements. This is a zone result, beginning with these sharp signs. So cloudy works by dividing the cloud into thin sheets called zones. This is the first one. This is about 8,200 Kelvin. This is an indication of the ionization. This is the ionization of hydrogen. So this means 0.1% of hydrogen is atomic. Mostly it's ionized, almost no H minus, H2 is almost none. This is so 30 elements information is given here. The grains have two materials, graphitic and astronomical silicate. Each one is resolved into 10 size bands, and all the grain properties are determined for each. The star indicates a quantum heating. Single photon heating is important for that species. So it computes the grain temperature, the floating grain potential, and the drift velocity. And then what's going to be very important is photoelectric heating of the gas by grain surfaces. Here's some of the molecules. Let's keep going. This is the last zone. By default, we report the first layer and the last layer along that shooting ray going into the H plus layer. The temperature has fallen down to 4,000 Kelvin. By default, cloudy will stop when it gets to that temperature. It started out at 8,000 Kelvin. So you see, hydrogen is mostly atomic here, only percent ionized, and others as well. The grain temperature has fallen. The chemistry will never be important in this model because we're not going into the molecular cloud. So these are some comments about the molecule, about the model. Uh, W would be a warning, which means that cloudy broke, and that should be that's very serious. Caution means something funny happened. This is about the radiation pressure not being fully converged in a zone. And there's other interesting, the bangs indicate something that's interesting. So now we begin again with the input deck shown here, and then these are the actual emission lines. So this is then a summary of this is some atomic data sources that were used in the calculation. This is a summary of some properties of the model, genes length, things like that. Then it starts giving some average quantities. So it's going to give some average temperatures, the average grain temperature, or the charge uh, integrated over the model. These are line optical depth, continuous optical depths. So these are all done self-consistently. Cloudy includes a large chemical network, and these are the molecules that were included. They're not important here because we're doing ionized gas. And finally, it reports some column densities and mean ionization, some general properties of the cloud, some convergence statistics, and then the end of the line file, cloudy exited okay. So that was all done pretty fast. But have a look at Hazy 2. Think about what you want to retrieve from the model. You can do a full text search and just have a look at what's in there in the output.